let's get some hands-on exercises done, and we'll explore a lot of APIs, and we'll do a lot of coding stuff along with understanding a little bit more further theoretical topics. So since this is more of a hands-on exercise, I would also recommend you guys to go ahead and do the same thing by following some of the examples and explore with different data points or with different files. Okay, so I'm pretty sure this is a very interesting topic, and it would be a very interesting session because it has a lot of interesting topics for us to understand and try it out. So basically what we're going to cover today is we'll be covering this entire session in 3 parts. So the first part will be talking about the analyzers, since it is very important for indexing as well as searching. So we'll try out all the basic analyzers, what you would be required to use in a day-to-day basic use cases. Okay, and then we'll be trying out and understanding all the different querying techniques or the different query types, and we will use both the API as well as the query syntax to understand and do some lab sessions on that. We'll also try to understand what is boosting, what is scoring, and then we'll try to address or understand all the advanced concepts like highlighting, faceting, joins, spatial search kind of thing. So let's quickly jump on to the analyzers part of it. So an analyzer is the initial step in our indexing or the search process flow. So yesterday we had seen the system flow, right? Once we acquire the document, once we acquire the content, we build the document. What was the next step, which is the first step in the analyzer? So the first step in the analyzer is the tokenization process. Once the analyzer picks it up, so it has to do some tokenization. Tokenization is nothing but splitting the stream of tokens or stream of words into words or tokens. Okay, so that is the process called as tokenization. So most of the time the tokenization accepts a string reader, which you can pass it to the tokenizer, and the tokenizer takes it from there and splits the words or the tokens and gives all the token stream. So now it is the token stream would be the output. So the tokenizer always takes a reader and emits a token stream as the output, so that the next filters, series of filters based on what you have chosen, it will pick up and it will do some sort of filtering. Say for example, if we have chosen lowercase filter, so each token would be converted into lowercase filter. And just in case if we have, along with lowercase filter, if we have used any synonym filter, so it will expand the each token if we have any synonyms to multiple tokens. So those kind of filters we can use it in conjunction with the tokenizer. So there can be more than one filter. Okay, and eventually the output of the token will be given to the index writer, which will take care of writing all the tokens into the index. Fine. And we also said it will be for different languages. It's not that Lucene can only handle for English or any particular language, so it can handle all the internationalized languages or localized content as well. Okay. So fine, so we have seen some analyzers and some filters, so I'll not dig into this slide a lot, rather we will jump into the actual analyzers itself. So let's start with a very simple analyzer. Fine, so let's start with the simple analyzer. So the simple analyzer, what it does is it picks token stream of text and it splits all the tokens based on space by default and only emits the characters data stream. So by default it ignores all numeric data or numeric characters, and also non-characters or special characters. So in a nutshell, it is a very simple one. It just uses one tokenizer, which is a letter tokenizer with lowercase filter. That's it. So even if you have any year or any numeric text, all of them will be ignored. So if you have any use case where you only have to retain the character stream and ignore all the numeric data or numeric stream in your index or in your documents, so the simple analyzer is the best choice to use in those use cases. Okay, so you might have noticed yesterday, so the very bare minimum way of instantiating any analyzer is the ones which are provided by Lucene core, and the analyzer component is simple analyze. Just say new instance simple analyzer. So the analyzer component or the interface or the abstract class remains same for everything, and you can just instantiate the simple analyzer. Rest everything remains same as is what we have seen from the yesterday's class. So the next one, what we are actually that one is not required. So the previous versions of Lucene APIs required to mention the version. So now you can remove the version as well. So I'll just show you. So this is not mandatory. You can just ignore, it will pick up the latest version. Okay. So the next analyzer we are looking into is the standard analyzer. So this one is just an extension of the simple analyzer, but it has a little bit more features attached to it. So in the earlier example, we have seen the simple analyzer ignoring some of the numeric characters and all of that stuff, right? So the standard analyzer, it does little bit different from the simple analyzer. First, it also uses lowercase filter and also uses a stop filter. Say for example, by default it has some stop words like all the common words in, a, the, and. So all those common words will be filtered. So in the simple analyzer, the stop filter was not used. So in the standard analyzer, there will be a stop filter along with the lowercase filter. Okay. So here in the standard analyzer, even the numeric characters will be emitted from the tokenizer. Okay, that's the differences, few differences from standard to simple analyzer. Okay. Fine. So this is again a variation of the standard analyzer. Say for example, yesterday we spoke about in some places you may have a little bit more control on the words. The standard analyzer restricts all the standard stop words, but it may not allow you to override your own bad words or anything of that sort. So in those cases, say if you wanted to restrict a few words getting into your index database, you can create a list of bad words or list of stop words along with the standard analyzer or the standard stop words. You can create a file or you can create a list of words, and using the stop analyzer you can stop all those words getting into the index. So that is the primary usage of the stop analyzer. Okay. So we'll be seeing all of these labs and the variations of it, so that we can, all the bad words can be given in a string with spaces. Actually, it is not recommended to use that in a string. Rather, we should be using it from a file, so that we can manage all of them in a file by line separated thing. So for the example, I just gave it like that, bad words. That's it. Ideally, a file should be preferred model. Okay, so this is very interesting one. So at times, say for example, you may wanted to search some words based on the root understanding of that particular word. Say for example, let's take a swimmers example. Say your document may contain swimming or swimmers. Say what if someone is searching with swim and you still wanted to match those documents and return it back. Okay, so in those cases you may have to use something called stemming. Similarly for the word like if your document has cat-like or catty or fishing, fished or fisher. So if someone is searching for say fish or fisher or fished or fishing, irrespective of which word they are searching, they have to match this particular document. So if your application or use case has this kind of requirement, so in those cases you have to use a stemming analyzer. So in the stemming analyzer also it expands the token vector stream so that you can search with multiple terms even though that particular document. So if I use standard analyzer and search for sim, I will not get results. Yes, of course you will not get, and we'll test all these things. Only if you use the stemming analyzer, if you use fishing, fished, fisher or fish, you will be able to get those results back. Okay. So basically the process is defined as to getting the base word of whatever we are trying to get search from the index. Okay, so we'll see at least a couple of these examples for this so that it gets pretty easier. Okay, so ideally when we create the analyzer, so there is algorithm by Mr. Porter. So that's the reason it's been named on his name, Porter stem filter. So there is a very exhaustive list of words what the Porter stem filter covers. So if you pass a string, the Porter stem filter will give you the base word for that particular string. Okay, so using the Porter stem filter, we'll be trying out this example. Okay, so there could be another requirement, or in some cases, say for example, you may wanted to add synonyms for a list of words. Okay, say if someone has to search for a word, say completed, over, ended, or finished alternatively. So even though your documents may not contain all these index terms, if you expand by providing the synonym list, so you can search with any of these words so that your users are not blocked with only the term which the documents are containing or only the index what you are looking for, right? So it is a very simple example, right? Someone can type in mobile phone, someone can type in cell phone. So if your documents only has mobile phone, if someone is typing cell phone, you should not stop bringing back those records, right, Venkatesh? So those are the kind of use cases we may have to go ahead and use synonyms so that we can go ahead and allow the users to do whatever they are looking for. Okay, so a very simple code snippet. So I have just taken the same example what we have provided here. So I have added 3 synonyms for finished. So for one, I have added completed, over, or ended. So the user can now search with either finished, completed, or over, or ended. Similarly, I have added 3 more synonyms for work as well. So job, labor, or effort. So it might be very tempting to get confused with the base stemmer or the stemming thing, but this is completely different. A synonym and a stemming is different because a stem derives the base word. So this is a synonym or an alternate word which you are adding it for searching for the users. Okay, is it clear? Okay, so the next topic we are going to cover is completely on the querying. So here we will be covering various query types. So the first few things which we will be covering, like term, Boolean, wildcard, will give us a lot of understanding of what exactly happens and how do we query different documents with different variations or with different flavors. Okay, so let's get into the details of it. Okay, so the first thing is a term query, what we have seen it so far. So in all these examples we have used something called term query in our search. So that was the reason it exactly looks for the term and it exactly returns the term if it matches. Okay, so that was the reason why you were not finding the partial strings or embedded strings. That's the first reason. So you have to provide or specify what kind of query type you are expecting the results to return. Okay, so if you use term query, which is the most basic way of searching or default way of searching in Lucene, will return only exact matching documents from the terms what you have provided. Okay, so there won't be any partial things, there won't be phrases, there won't be wildcards or anything in the default term query searching. Okay, so the term query, all you need to do is just say which is the field you wanted to search, and on that field what is the term you're looking for. As simple as that. Okay, now is it clear why you are not finding the embedded or partial results? So if we have to go ahead and do the embedded or partial results, we have to do a different query, and also you may have to change some of the analyzing terms as well. Okay, the tokenizer also may be changed if you have to use a partial or embedded things. Okay, so say for example, if you really wanted to do the embedded search, so in those cases we may have to use the n-gram tokenizer, where every token is again split into n number of characters. So n-gram is the weightage. Say for example, if you have, let's take the Edureka example back. Okay, let's say you have a token called Edureka and you wanted to search embedded strings like say URE. Okay, so in those cases you may have to use an n-gram tokenizer, where you need to specify what is the value of n. Say if you say the value of n is 3. Okay, so each token will be split into combination of 3 grams. Okay, say for example, edu will be one token. Okay, dur will be one token, ure will be one token, rek will be one token, eka will be one token. That is how the n-gram token will be split, and then you can search the embedded embedded words from the actual tokens what you had it in the index. And the n-grams need not be stored in the document, but it can be stored as the index. So this is a little bit more advanced topic, which we will be covering it in the Solr, not in the Lucene. Since Lucene we only wanted to cover the basics and the topics which is very important for us to understand, so we are covering n-grams, we will cover it in the Solr. Okay, so let's take what is term range query. So everything remains same. The only difference is that we are asking for particular range which matches the terms in the lexical order. So lexical order is, so any byte character in the lexical order, if it falls into that term range, it should return all the term ranges. Okay. And also, if you notice, there is something called inclusion or exclusion. So when you provide two range of terms, say term could be of any length. If I say between A and S, you return me all the documents. So it would return all the documents between A and S. And those A and S can be either inclusive or exclusive, and you can provide that including A or just exclude A and provide after A kind of a thing. Okay, so all those things are possible in the term range query, and we'll see a couple of examples which will make it easier for us to follow or understand. Okay, fine. So term range queries are not intended for numeric range. Say if you wanted to query numeric range, like say dates or integers or anything which has to deal with numerics, so you have to use a numeric range query, not a term range query. Okay, so everything else remains same. So you might have noticed in all the three examples, there is only one thing which is changing. Any guesses, Venkatesh? What is that on the code box? Just only one thing which is getting changed. What is it? Yeah, the query type, right? So here we are saying term. Here we are saying term range query. Here we are saying numeric range query. Here we are saying prefix query. Okay, so except that everything remains same in the querying aspect of it. Okay, so the prefix query is, so now we'll come to your example. You said I wanted to search for edu and show me the edu results for matching Edureka thing. So using prefix query, you can search for partial results. Okay, but the condition is prefix. So only prefixed characters will be searched, not embedded. Embedded is completely different, and you have to use a n-gram tokenizer for that. But prefix is, if you know the starting characters, you can search for those starting characters using the prefix query. Okay. Fine. So now the wildcard is a little bit different. So the supported wildcards are the star or asterisk and the question mark. So the asterisk represents, it can be 0 or more characters, and the question mark designates it has to be only single character replacement. Okay, say for example, if I know there are some characters in between which I'm not very sure, you can put a asterisk or star symbol. And if you are very sure there is only one character which I am looking for, say for example I wanted to get all three character words which are indexed between say B, question mark and T. So it will return say bat, BUT, but, all those kind of things. Okay. So phrase query. So far whatever we have dealt with were all term queries. When I say term, it is single word. It is a single term. Okay. It treats that entire term as just one word. So you cannot write multiple words, or you cannot search multiple words in that particular approach. Say for example, if I really wanted to try a couple of words as what I'm typing it in Google, kind of a search engine. So in those cases, you may have to use something called a phrase query. Okay, so the phrase query lets you search for multiple words at a time and also allows you to set a slop. So the slop is nothing but, so what is the acceptable distance between each word from the tokens. Okay, say for example, if you say the slop of 3 between, say if you are searching for French fries as a phrase query, French might be somewhere in the document, fries may be somewhere in the document. Okay, so the distance between French and fries, if you specify not more than 3, if a word is say French, okay, in French there are people who like fries a lot, if that is a sentence, okay, and if you had said the slop is only 3, would it find the document French fries? Would it match? Exactly, no, because you have set the slop, the relative threshold is only 3 and there are more than 3 words in between French and fries. If you make it maybe more than 10, yes, of course it will match French fries and it would return the documents. Okay, so that is the purpose of the phrase query. So again, if you notice, there is only slight variation. So you have to add all the terms as a phrase and then pass it to the phrase query and set the slop. That's the way of doing the phrase query. Fine. So now we have seen term query, range, numeric range, term range, phrase. So what if I wanted to search on multiple fields based on and or kind of conditions, right? Say for example, I have 4 to 5 fields in a document and I wanted to search on those multiple fields. Let's say I wanted to say if it matches on field 1, it may or may not match on field 2, those kind of and or condition. So those kind of queries are done using Boolean queries. So using the Boolean query API, you can say what is required and what is not required. Okay, must designates and it says that term has to appear for the document to match at any cost. Okay, should occur dot should says it is optional. If you are looking for that parameter, it is like optional. It may occur, it may not occur, just ignore it. Okay, if it occurs, well and good. If even it doesn't occur, it's not an issue. Not is basically, must not is that you only return if it does not match your word in that document. It is the other way around. So these are the 3 aspects which you can use in the Boolean query and retrieve records from searching in multiple fields. Is it clear? Fine. So although Lucene, we have seen different APIs, using APIs we can just go and write code. Sometimes it may be really painful to always go and write APIs or change APIs. So Lucene also provides an alternate way of querying, which is like using the query parser, and instead of writing the APIs, we can use a query parser and the query syntax to retrieve the data what we are looking for. So just by writing one query parser, we can pass in the entire query syntax and get the results back what we are looking for. So earlier we were using the APIs. Now instead of using the API, we are using the query parser and writing the query syntax, something similar to SQL. If you notice, name is the field and I'm looking for Edureka in the name, or name can also contain brain for C. So either one of them, if it matches, return me the document. Okay, so this is how the Boolean query is done using the query parser. Okay, we'll see different variations of query parser. So before getting into the lab, so let's see some of the basic query syntax terminologies. Okay. So as I mentioned, fields or the field names has to be mentioned using or a separator colon, and thereafter you can specify the content. Okay. The terms are specified without any string quotes. If you wanted to specify phrases, then you have to specify double quotes. Okay, and you can use Boolean operators and you can provide any number of fields using the Boolean operator. Okay, so similarly, wildcard, you can say the field name colon what the text you are aware of, and you can provide a wildcard. Okay, so there is a restriction on the wildcard. So the wildcards cannot be used at the beginning. Okay, wildcards is only after at least one single character. Okay, you cannot prefix a wildcard in the beginning. So similarly, a range search is used basically field name colon square bracket the value starting value to the ending value square bracket. So that is how we use the range searches. So I'm just covering the basics of it. As we get into the details of it, we'll see some of the differences between the API as well as the query syntax version of it. Okay. So now let's just go through all the different query and all the different ways of. Okay. So as I mentioned, so we can query the data which is already indexed in two ways. One is using the query Lucene APIs, and the other way is having the query syntax and using the query parser. So we'll try both the models and see if we get the same or exact results in both the approaches. Okay. So let's go to the module. Okay, so I'm in the module. So let's try the term querying as our first example. So even before trying the term queries, so let me go and see the documents what I've got. Okay, so seems like I have got some grocery list. So let me just go ahead and try this. Okay, so I'm looking for apples. So apples were there in file 2 and file 3. Okay, so file 1 didn't have apples. Yes, file 2 has apples. So I got apples, and also file 3 should have apples. Yes, file 3 has apples, and any other file should not have any other content. Yes, of course. And if you notice, this was the term query demo. Let's try something different with this. French fries. Okay, so I saw French fries, I believe, right? What do you think? Will it return term query French fries? Yes, absolutely, it should not. Because this is a phrase query, it won't match French fries. Okay. If you look for only French, yes, of course it will return. It should return, right? Or if you look for only fries as well, it will return. Okay, so that is the basic difference between a term query and a phrase query. So let's see if we have, okay, one more use case. Let's try apples. So we have seen apple, okay, and French fries which had a space. Let's try apple. This is more like a prefix query which should not work. Yes, it didn't work. And French fries we tried. And since we are using a standard analyzer, it should also search for the numeric characters. I'll just show the code as well. Yes, so let's quickly go ahead and check the code as well. So term query and demo. So I have got very simple two methods. Okay, first thing is I'm indexing. As you see, I'm using a standard analyzer. That's the reason I was able to search numeric as well as text tokens. And I'm adding list of files into the document. So this is straightforward, which we have been looking into it. And if you notice, I'm using a term query. Okay, so that is the basic difference. Okay, rest all is as usual same from displaying, retrieving the content and all. It is more or less same. Okay. Let's do one more thing. So let's go ahead and see the query parser code little bit, and then we can just go ahead and see how to do with the query parser. So we have seen an API approach. Let's see the query parser approach. So here I pass I'm not using any query term or term query or anything else. So this is a very generic query parser which I'm passing the search string and I'm executing the query. That's it. Nothing more than that. So let's quickly go ahead and try the term query using the query parser approach. Okay, so let's try this few examples which should have more or less similar effect on what I'm looking at. Yes, of course, I was able to find. Yes, content is the field name. So that's what I have mentioned. So the query parser syntax. So when we added the document, I'll show you. We added with the field name and the content. Okay, the field which we added, field name and the content. The field name is the contents. The field name itself was given as contents. That's it. That's the reason we are searching with contents. It can be anything. It is not mandated that it has to be always content. It can be anything, whatever we like. Okay, so let's search the same example of Apple. Okay, Apple, you should not find it, and 2012. So since we are searching, we are finding it as queries. So French fries as well, you should not be able to, but here it is finding. Any guesses why it is finding French fries in the query parser? Venkatesh? Okay, so a query parser is a very generic parser which doesn't know what kind of query it is. So it is treating that as a phrase query. So for just to give an example, so here contents, you can also try to give it like this. Okay. right? So it is treating this as a very generic parser, and it is taking it as a phrase query. So you can try this both. Now it treats as a term query. Okay, if you use this as French fries, this treats as a phrase query. That's the reason why it is able to I don't think there is any preferences of order or preferences. The moment it sees that it is not a single token or a single word, it thinks that it is a phrase query and it executes it as a phrase query. The moment it sees it is as one single word, it treats that as a term query. As simple as that. Makes sense, right? Okay, so we have seen these examples and the behavior between the API and the query parser. So the same query parser example can be used for anything. Let's say, now let's see this. Okay, see the same query parser example. Now this is treating as a wildcard parser. So we can do anything because I know the query syntax, so I can do it in any ways. But that is not possible in the API. Every time you have to change the API if you wanted to use something different. Okay, that is the reason why the query parser and the APIs would behave differently at times. Fine, let's see the next set of examples, which is the Boolean querying. So as I said, if you specify your term, okay, as must, then it should always occur. The term, it signifies that the term has to occur, okay. And if you say should, okay, it is that it can be optional. And if you say must not, then the term should not occur to match the condition, okay. That is, maybe in some cases you may have to have that kind of a necessity to provide that kind of operator, okay. So the Boolean querying is always aggregation or composition of terms or phrases, okay. So you can have multiple terms or phrases composed by it is not terms or queries, it can be anything, range, it could be any expression which can be composed with and or. Okay, let's try some of these examples. So I'm seeing some results, okay. So I have provided some Boolean query in my API, which I have embedded. That's the reason you could see the moment I started the code, it started running. Okay, so if you notice, I have one Boolean query which I'm looking for mushrooms and steak. So I am saying both mushroom and steak should be present in my first query. Okay, so if you notice, it is giving me a file which contains mushroom and steak. So let me just go and check file 3. Only file 3 has got both steak and mushrooms. So no other file has steak and mushroom. Okay, let's try file 1. I saw steak. Okay, it has got mushrooms but no steak in it. 2, it has got steak but no mushrooms, right? It's the same file. No. 5, no. 6, no. So almost all the files, only except file 3, it has got steak and mushrooms. I'll explain this what is exactly when I get to the query syntax of it. Okay. So the second example what I'm looking at here is milk and eggs. I'm saying both of them has to exist. So I searched and I found it only in file 3, which has to be true, I hope. Yes, only file 4 has milk and eggs. Okay. And the third example, I think I'm saying I should have mushrooms, but not, but optionally it's okay if I have mushroom or steaks. So initially only file 3 has matched. So now the file 2 also got included because steak I made it optional. Okay, sorry, file 1 also matched because steak I made it optional. Okay, so similarly I could say more examples like cheese is must. Okay, mushrooms, it's okay if it matches or not matches. Steak also it's okay if it matches or not matches. Okay, so written all the documents, okay, which follows this criteria. So I have added few more examples. That's what you could see it on the screen as well. Okay, so now let me explain symbols what we are using it here before I start the query parser way. So this is the field name, the contents which we are looking, colon the value, field name colon value. Okay, if you notice here I'm saying plus, which says that this field value has to be mandatorily matching. Okay, this says mandate, and here the steak also has to match by mandate. If you notice, if I say hyphen contents, it says it should not match mushrooms. Okay, if I don't specify anything, then it is optional. Either it can match or it cannot match. So that one is not mandate to match that particular term. Okay, is this clear? Venkatesh, Prakash? Yeah, no, or is a little bit different. Okay, this is a bit different. Or is used to compose the queries compose the terms based on different phrases. That also we'll look into it, but this one is mandating that it has to match it. Some of them it should not match it. Okay, some of them can be optional, something like and or if else kind of a thing, but not exactly and or. Even you can use and or in this phrase as well. You can mix the mandate as well as and or also, both. Okay, so it looks similar but it is not, but you can mix both of them here. So that is what we have done. So let's try the same thing by passing instead of using the API. So here if you notice I have used API. I have not used the query parser syntax. I have used the APIs and I have executed it. So now let's try going and executing the same thing using the query parser syntax way. I'm using the same query parser demo class file, so I have not changed anything. If you notice, now this is the syntax which I am passing. So I'm saying mushrooms has to be there and also steak has to be there. Okay. If you notice, I found it in only one file. Similarly, I can try other examples. So let me try one more test. So I found in only one file. So similarly, let's try one more example of not, or a little bit complex example. Let's try this one. This was our last step validation. I did not find any documents. So what I'm saying here is cheese is mandatory, mushrooms should not be there, steak should not be there. Okay, let's see. Only cheese is mandatory and mushroom and steak should not be there. Is there any file which got cheese but not mushroom and steak? Cheese is there but steak is there. That's the reason it didn't match. Cheese is there, steak is there, mushrooms is also there. So it didn't find. Okay, so that's the reason it did not find any of the files. So file 5, 6 and all is different ones. So I'm not looking into it. So that's the reason it couldn't find any of the documents. So sometimes you may want to restrict mandate saying I should not want to find something, then you match the document. Okay, so let me clarify the example of between mandate, this symbol versus this versus and or. Okay, so you can group using operators and you can say plus content mushrooms and say some other field. Say we had last modified file, okay, something like time range. So you can use all these kind of conventions. So that is the basic difference. Okay, does it make sense, guys? Yeah. So let's see the next example what we have got. Okay, the next one is the phrase querying. So here instead of using the term queries, I would have used the phrase query API. That could be the only change. Apart from that, I don't see any other change. So let me just show you that. Yeah, see, apart from the phrase query, I have not changed anything else. Okay, so everything else remains same, and I also set a slop for the distance between what is the threshold distance I need to restrict between those two words. Okay, let's try some examples on it as well. So I'm saying French fries and the bare minimum distance which is acceptable is 0. So I'm saying French and fries, there should not be any other word in between. Okay, even if I say 1, it will return because 0 is minimum. Okay, that's what I'm looking for. So let's try a little bit different. So let's try this example. Oh. What's wrong with it? Phrase query. Dollar is not. Oh, okay. I think I copy pasted exactly the. Fine. So here it says milk and eggs it cannot find. In fact, I have a file which really contains milk and eggs. Okay. See, milk and eggs are there. Just because there is a word in between, it is ignoring that term. Okay, if I have to get, okay, if I have to get milk and eggs, what should I do? Any guesses? Yes, at least the minimum slope should be 1 at the end. See, now I got the results back. So if you have to do something like this, where you want to ignore the tokens in between, you can set a slop. Okay, most of the time you may not know what is the distance or the relative thing, but based on what is that you are probably expecting, you can always set a slop and look for the phrase queries. Okay, let's see what is the other example. Yes, we have changed that to 1. Now let's see one more example. Okay, so it was there in file 2 and file 3. So file 4, since milk and eggs were there in the same line, it may be perception that the terms has to be on the same line, not required. If you notice, what is that we searched? Hamburger and apples. See, hamburger is on a different line, apples is on a different line. So all the terms or tokens, it does not matter on which line it is. So as long as there are token word distances within the threshold, it will go ahead and find those documents. Okay. Fine. Now let's try the query parser approach. So if you notice, I'm providing the syntax being printed on the console itself. Any guesses what could be the symbol or character we are using to signify the slop for that particular word? Any guess? Guys? So just look at the screen. So we are having some symbol which we are using it, right? It is the tilde symbol, which we could see it in the query contents. So we are saying content colon milk and eggs. Between milk and eggs, I am saying slop of 1. Okay. So the thing which I am using to specify the slop is the tilde symbol. Okay. Did you guys notice that? Yeah. So let's try the same thing in the query parser as well. So let me use the same query parser demo. Okay. And let me just see this first thing. Okay. So this one is interesting. Okay. So what did it really find? Any guess? File 1, 2, 3. It found French fries. What did it actually find? What did it actually do now? It did a phrase query, right? So the phrase query sometimes can also be done like this. So that was the intent, or we could also have done a similar way of doing this. This is also a valid one. Both are valid ones, just a different flavor which I just wanted to showcase. Okay. Say for example, when you are trying to do the slop, so the slop has to be set on the string inside, so that's the reason we are escaping the string codes. Okay, so you should not find any documents, and if you say one slop, I hope it should be able to find. Yes, it is. So this is the way how you can run the query parser using the tilde symbol. Okay, so you can combine all of these things to form a very complex query syntax as well. So we are learning the basics of the individual components. Once you combine all these things, it can form a very robust query structure as well. Okay, fine. So now let's come to Venkatesh's question. Okay, how do I do the prefix querying? So I wanted to do search based on the prefix words, like say Edureka. I wanted to search if it is matching only with edu as well. Fine. So it won't be anything different in the API way. The only difference is you would see there is a API which says use prefix query. That's the only difference. Rest all remains same. You are saying term, prefix, and you are adding a term. What is that you are searching for? Let's go ahead and search. So we do have apples, right? So let's search for app. See, we have found apples in 3 files, right? We can search it with like apple as well, right? So since we tried earlier with term query, apples were let's try edu. Vintage example. See, now it found it in 5, 6, 7 files. Earlier when we were using plain term query, this was not working. Okay, now either you have to use a wildcard or a prefix query, something like this. Okay, so it can be, it's not mandate that you have to have few characters. It can be also starting with any individual character as well. And I think yes, we can use query parser also. We are trying that next. Okay, so let's see this. One more last example. See, we have a lot of characters starting with S. Let's see first S, and it should have 2 or 5. So there are salad in one file, 2 and 3, and steak. Let's see steak in which file. So both of them are in both the files. So no worries. So let's see the query parser approach. Okay. So this is the query parser approach. I'm just trying it out. Every time this thing gets stuck here. Okay, so this is the query parser approach. So do you guys see any different so the moment you remove star, it won't be able to guess what kind of because it becomes very ambiguous. Okay, so it thinks it is as a term, because we are not signifying anything like this is a prefix query or a wildcard query. It doesn't know what kind of query it is, so it thinks that it is a term query and doesn't return anything. That's the reason we have to specify that it is a phrase query, prefix query or a wildcard query. Okay, so this it treats as a prefix query, and then tries to fetch the results. So similarly, you can see it can be for anything. Okay, so let's see. No, it will throw in error saying that it cannot, or the wildcards or prefixes are not allowed in the first. Okay, so wildcards or prefixes are only allowed in the post. At least you should have one character. That is a basic requirement. Okay, so let's look some range querying stuff. We said we can do range queries. So one thing, keep it in mind, guys. So whenever you use range queries, if you need pure numeric range queries, so better use numeric range queries, not range queries, because numeric range queries are much more efficient and faster. Okay, so I will just show you the code. I have not put any files or any input text, so I have added examples here. So I had added few examples. So I'm using range query, if you notice here. Okay, term range query. The first example I'm looking at is into the term range query. I'm passing few values. Okay, since it is treated as byte reference, okay, since term range queries are used for characters, so even if you pass numerics, it would be treated as byte refs. Okay, so it looks for data in between lexicographical order between 2013 to 2012 to 2013. Okay, so be cautious while using term range query. Okay, do not expect that the results will be according to what you are expecting it has to be. Okay, so the results, if you are expecting it to be based on the numerics, so then don't use term range queries for numerics. Any guesses why, guys? Meanwhile, I think Prakash had something on the prefix star ABC wildcard. Is this right? Yeah, prefix and wildcard, they more or less work same way, because again the prefix gets translated to the wildcard syntax and the API. So they both more or less both are same. So I have a question, guys. So what do you think would be problematic if we use numeric range and we use term range query? Sometimes it may work, sometimes it may not work. What could be the probable reason? One reason why it is not recommended and why you should not use is because when you say term query, it treats the numerics also as text. Okay, so it is treated in the order of lexicographical order. Say 2012 and 2013 lexically they might fall in the order. There could be some numeric texts which will not fall into the lexical ordering. Okay, so that is the reason. Lexical ordering is basically based on the ASCII value of that particular character or text. It does not count the numeric value of that particular string. Okay, that's the reason it is recommended not to use, but still in most of the cases it would work. Okay, and also it is slower. Okay. So let's try some examples. Oh, I think we already tried. Let's see what it has got. So the first example I tried from 2012 to 2013, if there are any documents, please return me all the documents. So the first had matched, okay, lexically, okay, it has matched from 2012 to 2013, it returned 2 documents. The second one, I'm saying 2012 to 2015, okay, return me all the documents, okay, it has written 4. So similarly between SA, between salads to steaks, return me all the documents. Yes, it has returned 2 and 3. So similarly between A and R. So let me go ahead and add one more document which only contains, so tell me something which can be between salad and steak. Let's try spin. Okay, maybe it's not the edible item, but still, just because I don't want to waste time, so I just did that. So let's try this one more time. So SA to ST, last time I found SA to ST 2 documents. Now I have 3 documents, which is file 9. So now you could see how you can do range queries for byte or character values, guys. Is it clear? Fine. So let's also try the same thing in the query parser way as well. Okay. So it is pretty straightforward and simple. Okay. I said as I am using two. Okay. Treated this as numeric and has treated this as a numeric range query, not as the API how it treated it as a byte range query or term range query. Is that clear? So similarly we can try more or less all the examples. I'm not going to try each and every example. I'm just going to try only few of them. Okay, SA and ST. Fine. Let's do some wildcard examples as well. So again, everything can be done in multiple ways. The one way is using the API, the other way is using the so since I have seen all these things, let me just go ahead and try this. No, let me just try with this one only to start with. What's wrong? Okay, there is a space in between. No worries. Okay, let me remove that space. Okay. So this is as what we have expected. So it used a wildcard and matched all the documents. Okay, let's try this example. So what happens here, guys, is not because of the string. First reason, this will not work in the query parser syntax. The star or the first wildcard does not work in the query parser syntax, but it works in the API model. Okay, so this is the API version, okay, which works in the API. In using the APIs, you can use the wildcard at the beginning as well. But if you are using it from the query parser, it is not possible. Just notice here, we are using the wildcard API and we are just passing it as a term. Okay, see, notice we are running the wildcard API demo, and if you are using the wildcard, you can still use the wildcard even at the beginning. That is the flexibility you get if you use an API. If you are using a query parser, it is not allowed. It throws an error. Interesting, right? Okay, apart from that, you can embed a wildcard in between as well. So let's try this. It should work pretty straightforward. Okay, so we said there are only two wildcards. One is asterisk and the other one is the question mark. So question mark designates only single character replacement, and if you are removing one, it wouldn't return anything. Okay, so let's go ahead and try using the query parser approach. Okay, so this one we have already seen, S star, so I won't do this again. So let's try this. S star, which worked in the API model, right, should eventually work here as well, but it is not the case. Okay. Again, there seems to be some space issue. Okay, fine. Fine. See, if you notice, the API clearly, the query parser clearly says star or question mark not allowed as first character in wildcard query, right? So that is the difference. If you wanted to still use star at wildcard as a wildcard, you can go ahead and use the APIs. Okay, and if you still wanted to go ahead and use the query parser, you can still do that, but you have to change the query parser implementation. In our case, we are using a very classic query parser. That's the reason it is not allowing you to use the wildcard at the beginning. If you change the query parser, you can go ahead and use the wildcard at the beginning as well. So I'm just sticking to the defaults so that we can understand the differences between all of these things. Okay, so I hopefully think we have successfully completed this topic as well. So far, what are the two topics we covered today, guys? So we covered analyzers and querying, different ways of querying. So you guys are liking this approach because this is the first time we are trying like each topic followed by lab, rather than longer theoretical jargons. So we are introducing this approach of every topic. At the end of the topic, we wanted to do the lab sessions. So if we all like it, maybe we can continue this in other courses as well, so that we don't get obstructed in between theory and actual aspects of it. Okay, thank you. So if this is the right thing, maybe we'll keep on extending it to other courses as well, so that people do follow all the theory and lab at the same time. Okay, great. So let's start the next topic. So the next topic is a little bit more interesting. Okay, these are all bit of more advanced things. So let's start with understanding the boosting and scoring aspect of it. Okay, so we have seen so the range is also applicable to dates. Okay, so it can be dates as well, so the dates are also applicable. So there is a format on which you have to specify the dates. It understands the dates as well. Yeah, the query syntax understands the dates as long as you specify it in the default format. You should be able to query the dates as well, so without any issues. Okay. So far we have seen searching all the documents by various ways, right? So we have seen list of documents, okay, matching and coming in. So in this case, we said we wanted to search all the records, and we got some files in a order. So any guesses what order this could be, and how do I control this order? The way how Lucene figures out is by using some default techniques. Okay, so the default technique is called as scoring. Okay, Lucene uses some default scoring techniques like vector space model and Boolean space model with TF-IDF weightages. I'll explain all of these things in detail. So the reason why you need scoring is to sort the records, which one has to come first and which one has to follow next. Okay, that is what we call it as scoring. So Lucene provides some weightage to each document, say a rank kind of a thing to each document, and then sorts all that documents in that order. That is what is called as scoring in very simple terms. So there are different techniques and different ways of scoring documents. So Lucene by internally uses TF-IDF as default scoring mechanism with vector space and Boolean space models. Okay, so I'll explain what are these things. Is it clear what is scoring in first place, so that we can get into the next topics? Okay, fine. So using a space model with some weightages, it gives you the scoring. So space model is nothing but representing your query as well as the document in a vector format. Okay, is called as a simple terms is called as a vector space model, nothing more than that. Okay, once you represent the document and the query in a multi-dimensional vector space, then assign the weightages to each term or the document. The conjunction of the vector space model and the weights will give you a scoring. There is the algorithm. Okay, we are not getting into the details of each and every step how a score is assigned to a document for ordering. This is a very high level overview of how a score is derived. Is it clear how a scoring algorithm is derived for documents? This is the high level approach. Make sense, guys? I'll explain what is this TF, IDF and vector space models very soon. Okay, this is the high level approach to derive a score for a document. Using this score, Lucene, when retrieves the documents, sorts it based on this score, and this entire approach is called as scoring. Okay, so very high level overview of the vector space models. So I'll not overcomplicate or confuse. It is just a collection of documents represented in a vector space, as simple as that. And also, as I mentioned, a query also represented in a vector, both a document, collection of documents and query. Okay, just to visualize it, I'll make it a little bit more simpler. Okay, a vector space model is nothing but, let's say this is a vector, okay, a two-dimensional vector. Let's say I have documents, okay, I have term, let's say Edureka, okay, these are all the terms, okay, courses, these are all the possible terms, okay. I'm just using two terms for now. This is a vector space model, okay. This is the document ID, doc1, okay, whether I found it in this document or not, courses I found it or not, doc2, I found only courses, doc3, I found in one, okay, doc4, okay, I found it, I didn't find anything of this. So this is how you can visualize a simple vector space model. Make sense, guys? Similarly, you can think of a query also represented in a similar fashion. What is that you are looking for? Let's say you are looking for contents, right? And you are looking for a term called Edureka. Okay, so this is a straightforward single dimension. If you're looking for multiple fields, like say there is another field, contents, okay, and you are looking for say courses as well. So this is another dimensional query dimensional vector, which is both represented in vector space model for querying the documents. Okay, so this is a very high level approach. When we determine the document collection and the highest vector space scores for that query, it gives you some weightage factor. Along with that weightage factor, using the TF-IDF, the score is derived. Okay, so there are a lot of scoring techniques. By default, it is figured out by a similarity metric. What is a similarity metric? Say for example, you have multiple documents. Okay, so now let's say I have multiple documents. Okay, so first of all, we represented it in a vector space model, and then I have to find similarities between these two. Okay, so maybe this is a very hard example. Let's take something interesting. Let's say milk, eggs, and bread and butter. Okay, so I have documents, okay, which says, okay, consumer 1, which is much more meaningful example, consumer 2, consumer 3, these are all the documents, consumer 4. So I somehow got these documents. I'm saying who and all is shopping for these products. Okay, a consumer 1 bought milk, eggs, and bread and butter. Okay, let me add few more examples. Guys, is this interesting? Shall I continue, or you guys wanted to move further? Okay, let's add few more. I'm saying wine, whiskey, okay, or let me say vodka, okay, and say, what is that you guys usually prefer with drinks? Tell me something, snack. What is your favorite snack with some drinks like vodka or wine? Okay, chicken, that's great, perfect. What else? Anything? One more choice of yours. Okay, chips, fine. So this is a shopping app, okay, where I have aggregated who is buying what. So consumer 2, he has bought wine, he has bought chicken and chips. Okay. Consumer 3, he bought milk, bread, butter. Consumer 4, he bought vodka, he got chicken, he got chips. Okay, this is very simple thing. So let me just actually show you how a file might have contained and how it got transformed to a vector space model. Let's say this is consumer 1 file. This is the actual file which had contents. Let's say I'm just adding what and all he bought: milk, eggs, bread, butter. That's it, as simple as this, right? So this is what the consumer has bought. After indexing, okay, it goes into consumer 1 file, and when I'm scoring, this is how a vector space model would have been represented. Okay, now how do I correlate between documents and derive a score? That is done by something called similarity techniques. Okay, the default similarity technique is called TF-IDF. Okay, so the TF-IDF stands for term frequency and inverse document frequency. Yeah, term frequency and inverse document frequency. So I'll explain all these things. Would you make any analogy between, say for example, a consumer 5 comes in, okay, he is buying wine. What is the probability that he will buy anything similar? He started buying chips or chicken, right? Great. Let's say chips and chicken he bought. Okay, so can you guys tell me, is there any correlation between consumer 5, 4 and 2? Is there any correlation between consumer 4, 5 and 2? Yes, no? Exactly. Say for example, if I am searching for a term called wine, ideally what should be the next document? Will you return the consumer who has purchased milk, eggs, bread? Right? Exactly. So you will return consumers who have purchased vodka, wine, chicken, chips. Okay, that is the idea behind finding similarities. How to find similarities is again a different technique which I can explain it. Okay, is it clear guys so far? Yes, it is exactly similar technique is adapted to find the scoring as well. Okay, recommendations is a bit different. This is to only derive the similarity and the scoring based on those similarities. Okay. It only applies to the indexed fields. Okay, it does not apply to the stored fields. All the analysis so far we have discussed is only for the indexed fields. Okay. So predictive analysis also comes in scoring. Okay, what does that mean? Okay, let me first explain what is TF-IDF, term frequency inverted document frequency. So term frequency is nothing but, okay, let's say I have this. It's a very simple calculation. How many times a term has occurred in a document? Okay, say if I'm looking, say what is the term count of milk for this document? 1. Perfect. Eggs 1. Bread 1. Butter 1. So that is what we call it as term frequency, as simple as that. Okay. So okay, I'll to give you one more example of consumer 2. Okay, consumer 2, it has got milk, eggs. So here what is the term frequency? 1, 1. Okay. So Prakash says, how many dogs does this word contain? Exactly. So document frequency is nothing but how many times this has repeated in the documents. Okay. So any guesses what is the document frequency of milk? 2. Absolutely. So inverted document frequency is nothing but inverse. You just divided it by 1, whatever the document frequency, you get term inverted document frequency, as simple as that. So when you multiply term frequency and inverted document frequency, you get TF-IDF, as simple as that. That is what we call it as weight or score. So very simple mathematical function which is used to derive the term frequency and the TF-IDF. Once you derive the TF-IDF, you assign it to the scoring. That's as simple as that. Okay. So it's a very, since we have to normalize the IDF, we use a logger to normalize the data points so that it is, you know why we use logs, right guys? Should I explain it or not required? Just to reduce the magnitude of the data points. Say for example, milk, if you have 10 million consumers, okay, and every out of 10 million consumers, 5 million consumers have purchased milk, so your number will be something very big like this, right? And also eggs. Okay, for practical calculation purposes, if you use bigger number for any multiplication, it will be exponentially growing and at some point it will break. This is a higher magnitude data point, right? This is a very higher magnitude data point. Just to normalize it into a smaller magnitude, we use loggers to normalize the data to a smaller magnitude so that we deal it in say 1.38, something like this, and we know exactly. It's very simple. Instead of you making this as a number, big number, you can just also say very simple technique like this, right? So you know that you are dealing with 1 point less than say 10 point scale magnitude, and you can multiply or assign scores better. Make sense, guys? Yeah. So that is how you have the scoring and TI-IDF calculated. Once you have the scoring, you can assign it to the ordering. By default, Lucene provides scoring algorithm using TF-IDF. If you want, you can change or customize your own scoring algorithms as well. So which is a very, very advanced topic. I wouldn't recommend for basic needs that you should go ahead and try all those things. Okay. Now let's do a score boosting. So boosting is, say for example, you wanted to alter the order the way how Lucene is returning. Okay. Say for example, you wanted to boost some records based on some value condition. If it satisfies to top order, you can boost those records. So boosting is done by two ways. Either you can boost the records while indexing and store it permanently inside the index, or you can also query them at the runtime. Okay, you can add boost at the runtime as well. Is it clear? Okay, so boosting at index time has to be done at the field level. So if you are trying to boost a particular field, you can select that field and say set boost, and you can add a numeric value. It has to be a relative value. So you can decide what should be the alteration factor based on the TF-IDF. Okay, we'll see an example which you can be very clear after that how the weights are allocated and how much you have to boost weights based on the weights. Okay, this is how you can do index time boosting. And similarly at the query time boosting, you don't have to do anything, just say query dot set boost and select the field. It will boost that particular term. Okay, so let's quickly jump on to the lab session. Okay, so I have got an example. Okay, so let me just open the document file. So guys, this is a very tricky topic. This is one of the tricky topics. You guys are clear on this? Okay. So let's first try the index time boost. Let's try the first one. Even before going and trying the example, I just wanted to touch base on the use case. Okay. So the use case we are trying to resolve is, I have list of cars or SUV in a data file, or I'm creating some data. Okay, and if anyone is searching the term SUV, okay, then since I'm searching from India, it doesn't make any sense if you return me a car which is not in India, right? Say there are a lot of cars from India, Russia, Japan, US. Ideally, what should be the SUV which has to return first if I'm searching for SUV? Which type of SUVs? I'll show you the input data as well. So here is the input data. I have got few cars. So I have Lada Niva from Russia, Tata Ariya from India, Nissan Terrano from Japan. Even India has that, but I'm just marked it as Japan. Mahindra XUV India, Ford EcoSport in US because it is a US vehicle. Just for marking, Mahindra Thar from India. Say you are searching for SUV from a Bangalore location. Ideally, which record should come up first? Guys, absolutely right. So without using the boosting, it is not ideal that you will get the right records in the right order. If you are using the boosting, it will always come up as India results as first. Okay, so let me show you the code example as well. So we have a index time boost, okay, and I'm putting a condition. If the item value is India, okay, then boost 2 points to that particular field. Okay, as simple as that. And then let me just go ahead and try this. Okay, notice you may see all the India vehicles has come up on the top and then followed by non-Indian vehicles. Is it clear? So now let's go ahead and see some stack trace of how actually it has happened. Okay. No, it is, I have selected that to give preference to India. That's why I have boosted 2 points. That I'll explain it right away. Okay, just notice. That's what we are trying to understand. Okay, so now if you see, there is some details like what is TF, what is IDF value, and what is the field norm kind of a thing. Okay, so if you notice, I found there is a value which I am trying to get it. Basically there has been a rank, okay, of 1.69. okay, and also if you notice there is another rank which got assigned 1.69, 0.8, 0.8 and 0.69. So what is the maximum value you could find in this list? Any guesses? What is the maximum value? 1.69. So the field normalization scale, just make a guess what could be the scale you can follow here. So that is the reason behind we have boosted it to 2. Okay, let's assume everything was less than 1 point, something like 0.09, 0.67, 0.25, 0.34. What should have been the ideal boost scale? Yes, so now you guys are aware how to choose the boost scale. Okay, so let's try one more example as well. So maybe we can try it with the query thing. So let's try the query time boosting as well. Okay, so query time boosting gives us a lot of flexibility so that we don't have to go and reindex every time. But query time boosting is a bit slower than the index time boosting. Okay. So the query time boosting also more or less gave the same results. So be cautious guys, this is different from query parser. This is query time boosting which we are using it again in the API. Okay, don't get confused with the query time parser versus query time boosting. This is query time boosting. I am setting the query time boost at the querying time. Notice here I am setting a boost value at the boost at query time. Okay. Okay, no, I haven't changed it. That's the problem. I have to change this to query. Okay, I still ran the same thing. That's the reason why it didn't got me the right results. Okay, can you make what is the difference between these for the first one and the second one? Yes, the scoring is applied on top of the search results at the query time. Can you make a guess what is the difference between the first one, index time, and the query time results? Absolutely. The second one, boosting was done on the color, and the index time boosting was done based on the country. If you notice here, the query time boosting, we use the caret symbol to boost a particular term. I have boosted value 2 for item color white. If someone is searching for SUV, it means if you find a match of white color SUVs, boost it by 2. That is the difference. Even the output should resemble and say the same thing. Is it clear now? If you see here, the first one, India came first in the order. If you notice, the Ford EcoSport Mahindra Thar came on top because of the white. Okay. Okay. So highlighting is a very straightforward concept. Say for example, if you wanted to highlight the term what you searched for. Okay. Let me show you an example of Google. So I'm searching for, say, term query. Okay. See, are you noticing that whatever the terms I'm searching, it's been highlighted here, right? This is what is called as highlighting. So if you need something like this, you can do it using the highlighting, using the Lucene APIs, which we'll just quickly take a look at it. This is what highlighting is all about. So index time boost is faster, but it is rigid, okay? Because the documents are indexed and sorted in an order. While querying, it blindly retrieves those documents and returns it back, right? The query time boosting has to be done in a way that it has to first fetch the results, then apply the boosting in memory, okay, and then return the result sets back. Say for example, if your result set is say 100,000 records, fitting all those 100,000 into memory, sorting it, assigning score will be a time-consuming process. That's the reason search query time boosting, people most of the time they don't prefer, they only prefer index time boosting, okay? Second thing is, index time boosting doesn't offer you a lot of flexibility, but search time boosting or query time boosting allows you the flexibility. You can immediately change the term from India to country, but it is not possible in the index time boosting. That is the basic difference, and you should always go ahead with the index time boosting because that is much more faster. And query time for debugging, testing, if there is very less less interactions, you can use the query time boosting. Make sense? So let's see the highlighting example as well. So it is very simple. Everything remains pretty straightforward. Okay. So when you are searching, the only change what you would notice here is, I'll first demo the code and then show the code piece of it. Okay. Okay, there seems to be a typo here. It has to be lab 7. Okay. Fine. So if you notice, okay, so we have searched, okay, it is again explaining all the TF-IDF. Let's assume this is the document, okay, and I'm providing this in HTML format, and I'm just highlighting where it has matched, okay. So what did I search for? Steak, right? So if you notice the actual content here, it is marked in a special tags, match, steak. See, it has matched in a special tags. So you can transform this special tags in CSS, make it bold, do whatever you want it to do. Okay? Is it clear, guys? Okay, yeah. So this is a very basic ones. Let's go to the much more deeper examples. Okay, so this is a very interesting example and very crucial example because this will be used across a lot of projects and lot of other places as well. So we have seen what is faceting is and how to control facets. Say for example, if you wanted to categorize groups based on some particular taxonomy terms. Okay, these are all called as group facets, or sometimes you have to define a taxonomy, how to group these dictionary, and then based on that you can go ahead and collect or create these facets. Okay, so there are few examples where and all you can see facets on different sites. Okay, and what type of facets you can come across. Okay, as simple as that. So let's go ahead and so let me open the Word document as well. Okay. So before that, let me show you something. I've got, let me delete this two things. So I have a JSON document. You guys are all aware of JSON format, JavaScript object notation. Yeah, it's something similar to XML, just to wrap the content in a particular structure. So I have list of books. I have an ID, title, author, and book category. Okay, so if you notice, there is a category which I'm defining here. Okay, novel, comedy, drama, so tragedy, all that stuff. Okay, so ideally what and all could form a facet here just by looking at it? Any guesses? Yes, so in book category, comedy could be one facet, and you can count all the comedy and say there are 2 comedy books, right? Drama could be one facet under category and say there are 2 drama books, right? And there could be other aspects like authors, if there are repetitions. Okay, yes, there are. So authors also could be something like that. So we wanted to create authors, we wanted to index and retrieve based on some different facets, which is what we are trying to do it here. So let's first go ahead and get indexed and see how we can retrieve this content. Let's first index it. Okay, I didn't change the folder, sorry guys. Okay, so it has indexed all the content. Now let's go ahead and search the content. Okay, so if you notice, now I could see some facets coming back. So it has created on author, okay, and it has created on book category, right? So using this facet categories, you can go ahead and create your own UI or your own stuff where you can filter it. So now we have seen how to achieve it. Now let's go ahead and see what it has got. Okay, so we have got an indexer and we have got a searcher. By default, this is what we do on every exercise, right? Okay, so I have created an index. If you notice, I have also created a category document builder. Okay, so this is the one which defines the facets for me. Okay, so if you notice some of these things, whatever I have, the fields, I'm writing it to the category paths, one for author, one for book category. So if you want something else, you can also define those categories, and the category builder will build it for your categories which you are looking for. Once you have created these 2 categories, then you can go ahead and search. So once it is created, you can go ahead and search. Search is again pretty straightforward. We don't do pretty much into it. You guys can always go through the API part of it. Okay. So say for example, if we wanted to get one level deeper, okay, in book categories I wanted drama, novel, all that stuff, you can also do that. So it has digged one level down where you can see it has novel has one drama, one comedy, all that stuff. Okay, so this is how we achieve faceting using the APIs. So this is a small variation. Say for example, after faceting, okay, or after retrieving the results and based on some grouping, you wanted to create subcategories of the result set. Okay, so this is this should be pretty straightforward, where no, scoring also can work at the index time. It is not that scoring only works on top of search results. Scoring works both at index time and at it is not scoring, it is actually the boosting. Okay, highlighting happens at the query time. It modifies things and it gives you a highlighted terms where you can pick what terms matched in the document. Okay, faceting is something which you have to define all those categories which you are looking for. That's the reason faceting is ideally best suited for at the index time. You have to define the taxonomy, right? What is that you are looking for? What is that you wanted to group? All that stuff. You can first do index. I have put all that stuff in the same place. No, it is not absolutely required. You can just do pretty normal indexing and then later you can do the data category indexing. Both are independent. They are not related. I have shown it in the same example. Okay, indexing is just to get, once you create the facet index, you can get the facet details as well along with the index documents. Okay, so grouping is again pretty straightforward. It just groups the subsections of the result set into one place, as simple as that. It does not offer you great flexibility or the way how database grouping offers. It is just grouping the similar documents into one place, as simple as that. Okay, so joins, again you can do both at index time or query time joins. So basically you can if you are doing index time joins, you can merge two documents into one single document. Say for example, as a parent and a child document, you can merge them and you can index and store them together. At query time joins, based on some conditions, you can club those documents and return it at one place. Okay. Okay, this is very important. The grouping, the joins, I would avoid using them most of the time because they are very expensive operations. The spatial search is very important. Say for example, if your application is looking for searching based on some maps or locations, where say for example, I need to find all the nearest hotels within 5-kilometer radius from the airport. Okay, in those cases maybe we have to use spatial search, where you have to assign some lat long or distances, or lat long is the best use case, and you know the airport lat long. So using two different lat longs, you can find the radius or the difference in the distance. Then you will be able to sort all the records based on the distance. Okay, that is one of the examples of spatial search. Is it clear what spatial search is, right guys? Okay, so these are all some of the screenshots of some of the applications. Okay, so let's finish off this thing and we'll go for a quick lab session one last time. So as I mentioned, Aapche Tika is a third-party open source library. Again, a secondary, when I say secondary or third-party library, it is not part of Lucene. That is the meaning of it. So you can use Tika for extracting rich documents like PDF, Excel, and all that stuff. And this is the acquiring step of the search index process. So if you want to acquire content from rich documents like PDF, PPT, CSV, all other files, you can use Tika and extract the content and build a document.